So friends, recently NASA put images taken by James Webb Telescope in public domain. These are truly mesmerizing, unprecedented photos which tell you interesting things about the universe. One of these photos gives us the oldest glimpse of the universe. We can see 13.1 billion years into the past. In another, we discovered an alien exoplanet where water or H2O has been found. Come, let's try to understand these new discoveries in today's videos. The James Webb Space Telescope is the largest and most powerful space science telescope ever built. Every image is a new discovery, and each will give humanity a view of the universe that we've never seen before. So the Webb is able to look at the formation of the first stars and the first galaxies. The Webb is tremendously exciting light from other worlds, orbiting stars far beyond our own. It's astounding. In many ways, friends, this telescope cost about $10 billion. It took NASA 25 years to work out its design and development. And most interestingly, the spot where this telescope is located, currently it is operating at the temperature of 266.0. It is so cold that it is almost at the absolute zero temperature of 273 degrees Celsius. Temperature cannot fall beyond that. It is only a few warmer than that to maintain this temperature. The James Webb Space Telescope doesn't orbit around Earth like the Hubble Space Telescope. Rather, it orbits around the Sun about 1.5 million kilometers from Earth. There's a point known as the L2 point. It is always in the Earth's in a way that it can safely orbit the sun. As you can see in this video, to block out the rest of sunlight, a sun shield has been attached behind it. It's nearly as big as a tennis court. Do you know what is the focal length of this telescope? Those of you who use DSLR cameras as a hobby would know the length of those cameras. It usually has the focal length somewhere around 24mm, 35mm or 50mm. The focal length of the James Webb Space Telescope is more than 2,500 times of it. 131.5 mm is not in there. Its main mirror weighs around 705 kg. Let me remind you that this is our electromagnetic spectrum. Different EM waves have different wavelengths in it. There is a tiny spectrum of visible light, the light which we can see with our naked eyes. Rainbow colors: violet, indigo, blue, green, yellow, orange and red. This wavelength ranges from 0.38 to 0.7 micron wavelengths. Higher than red are known as infrared. And the wavelength on which this James Webb Space Telescope can take pictures in ranges from 0.6 to 28 micron. There is a small overlap with the visible light. But mainly this telescope works with the infrared portion, can look through the gases and clouds. Because of the larger wavelength of the infrared light, the longer the wavelength, the easier it is to go through objects, such as radio waves whose wavelength is measured in kilometers. We can listen to them through the radio. Those waves can travel, pull through our homes and walls. Two infrared cameras are mounted on this telescope. The near-infrared camera aims to capture the shorter infrared wavelengths, and the mid-infrared instrument MIRI-cam to capture the longer infrared wavelengths, depending on the camera used by the telescope. The photos vary. Look at this photo. This photo taken by the Encom, truly breathtaking. It went viral on social media when the photos were released by NASA. But the same photo was taken by the MIRI-cam as well. And the same thing looks like this on MIRI-cam. The dust clouds which were visible don't show up much on the MIRI-cam, because the wavelength captured by MIRI-cam is longer, so it is easy for it to pass through objects, enabling us to look through the clouds. You might ask now, what is the thing in the photo? What are we looking at? Friends, the answer to it is we are seeing the death of a star. Yep, that's correct. We can see the star dying. There are two stars in this photo, orbiting around each other. The brighter star of the two is at the early stages of its life, and the dim star is dying while dying over the last thousands of years. This star has been releasing clouds of gases and dust. The cloud of the gases and dust is known as the planetary nebula. And because the two stars are orbiting each other, the cloud keeps getting swished around, similar to how you mix sugar into the water, because of the gravitational pull of both stars. This is the shape of the cloud. It is interesting to note that in the Encom photo, you can see only one star. And you can see the cloud clearly, but in the MIRI-cam photo, the cloud is quite muted. Andy, you can clearly see the two stars as I explained. Because of the longer wavelength, we can see the center of the dense cloud. If this is the first time you're hearing about stars dying, shocking, isn't it? I'd like to tell you that similar to the life cycle of humans' childhood, teenage, adulthood, old age, and then death, similarly stars have a life cycle. To our soonest star as well, it is quite young now. About 5 billion years later, our sun will become a giant. After becoming a red giant, it too will go through the same stages. That these stars are going through, in this photo, it will become a planetary nebula, after which it will be a white dwarf. And then the red giants are bigger in size than an average star. When our sun will turn into a red giant, it will swallow the planets of Venus and Mercury, and Earth will no longer have living conditions. But don't worry, humans have 5 billion years to discover some technology which can push back Earth's orbit, but that's for later. There's now talking about it. Now let's talk about the rest of the photos. The first photo released by NASA was this one. It is perhaps the most historic photo too. This photo glimpse from 13 billion years ago. After seeing this photo, American President Joe Biden said that it is a new window into the history of the universe. And today we're going to get a glimpse of the first light to shine through that window in this photo. We can basically see a galaxy clusters, max 07 to 3. The galaxies closer to a camera have a high gravitational force such that they are distorting the light coming behind them. It creates a magnifying glass of sorts. This phenomena has been named gravitational lensing. With its help, we can see objects behind it. It isn't a photo which was simply clicked by the telescope. Ours is similar to how you point your camera, tap a button and take the picture. It's not so it took 12.5 hours to take this photo. In it, the galaxies that appear redder in color are farther from you. The redder the galaxy, the farther it is. While we're discussing the distance, look at the next photo. This has been named Stefan's quintet. It is a cluster of 5 galaxies. The prefix aquina is used for the number 5, such as a quad is used for 4. This quintet is more of a quintet because the leftmost galaxy among them are 40 million light years away from you, and the other 4 galaxies are about 290 million light years away. You can see the photo of the leftmost galaxy looks more HD if you zoom into this photo, while the other 4 galaxies look quite blurred. These 4 galaxies are so close to each other that the dust and stars present in them have started interacting with each other. We can see the effect of their gravitational forces on one another. To scientists, this is immensely interesting to see. The scientists want to know what happens when galaxies get so close to one another. Next is the most beautiful photo till. In it, we can see the birth of our star after seeing the death of our star. We can now witness the birth of our star, the mountain range kind of thing that you see have been named as cosmic cliffs. By scientists, this is again a nebula. Nebula means a bright area formed by the clouds of dust and gases. You can think of it as a big shiny cloud. This specific nebula is named Karina nebula. If we go back to the life cycle of our star, you'll see that a star is born at the stage of our stellar nebula. In this photo, we can see the birth of the stars. Their dots in this photo are basically growing infant stars. You can see this from NCAM and Miriam both. Friends, now let's come to our most interesting photo. I just note when a photo, but this has piqued the curiosity of scientists. The most it is a spectrographic data of the planet was 96-bit is an exoplanet 1150 light years away. From exoplanet is a planet that lies outside our solar system apart from the 2 cameras. The James Webb Telescope is equipped with NI stands for near infrared imager, and slitless spectrograph. Spectrograph is an instrument which measures the intensity of the various wavelengths of light for 6.5 hours. Then here us measured the light coming this from the planet. The result of the measurement was this light curve. The data plotted on this graph tells us that there's water on this planet. H2O, additionally there's some haze and clouds as well. You might wonder, how can we determine a planet has water or not? Simply by measuring light. Even though we haven't even seen its photo, the answer to it is very simple. They have estimated that the temperature on that planet is more than 530 degrees Celsius. So the chances of finding aliens on this planet are next to none, but over the next few months. The James Webb Space Telescope will analyze another planet. It will be pointed towards a new planet to take pictures of that planet, which is said to be one of the most potentially habitable planets. If a certain combination of these gases is detected, it will help us to conclude that there might be life on that planet. Let's wait for the future discoveries made by this telescope. But when this is for sure, the scientists believe that if any exoplanet there's to sustain life, 3 main things should be present there: liquid water, a solid surface, and an atmosphere. I hope this video was as informative. Let's meet in the next video. Please subscribe my channel and like video.